Miss Green, doing this. Great. All right, Miss Green. You and me. Miss Green. Here we go. Let's do it. So, first up, I'm going to draw each of the two vectors all by themselves. Am I wrong? Okay. So, I'm going to start by doing this. Except I don't have a pen. I'm going to start by doing this. Oh, I need to turn off the lights. Here we go, like this. And I'm going to draw 20 feet, 30 degrees. Agree with me? That's the first vector. Miss Green, see where I got that from? Rest of the class, I know, whatever, just give us some time. Okay, the second vector is going to look like this. It's going to be 100 at 60 degrees. Agreed? Okay, now we're not adding them the way we normally would. We're just simply writing them down so we can do them in components. Regular components. So I know this piece right here would be x. This piece right here would be y. Agreed? Yes. How do I find what x is? Cosine of 30 degrees. Whoa. Going too fast. Slow down. Cosine of 30 degrees equals x over 20. So 20 cosine of 30 degrees equal to x. What do I get when I do that? 17.32? 0.3. Interesting. Okay. And then let's do the y component. So that would be, how do we get the y? Sine of 30 degrees equals y over 20. So 20 sine of 30 degrees equals y. Y equals 10. So over here, I'm keeping my tally. Vector 1 is equal to how much in the I direction? 17.3 I hats plus 10 j hats. Great? All right. So now I'm going to go back over here. I got to do the second one. Walk me through the second one. So to get x, I would do what? Cosine of 60 degrees. X over 100. 100 cosine of 60 degrees would be equal to 50, you said? I'm with you. 50 I hats. Plus, how do I get the y? Sine of 60 degrees is equal to y over 100. 100 sine of 60 degrees equals y. 86.6. Love it. So 86.6 j hats. Now, I've just broken into components. Great. Listed my components, stacked them. I'm now going to add them up. Figure out how far the whole triangle would go to the right and how far we go up. So I add up these two and I get absolutely. That's why I'm doing with you, to see if I'm going too fast, too slow, what am I doing right, wrong. So I appreciate your help on that. Went to the bathroom and you came back with a coffee cup.
No,
Hey, I'm not judging. I just, whatever you, yeah.
I left with a coffee cup.
Just, I assume you had a health class. You know, whatever you need to know. Okay, ready? So add them up. What do I get? 67.3 I hat plus 96.6 j hat. And what are those? They are the of the resultants, right? Okay. It's how far it goes to the right and how far it goes up from my resultant. So I'm going to start at my little centerpiece, and I'm going to go 67.3 this way, and I'm going to go 96.6 this way. Agreed? That is not to scale. I apologize. Now I'm going to go, whoop, there's my resultant. That's what I really want. That's what the goal is right there. It's in sight now. How do I figure how big that resultant is? A squared plus b squared equals c squared. So that is 67.3 squared plus 96.6 squared I'm developing dyslexia right before you realize. 117.7 at 90 angle. Drop my theta from the beginning point. So what are the two sides I know? Well, I know all of them, but these are the two I got started with, right? Yeah. So I made a mistake here. I'm not going to do it twice, right? Okay. I'm going to use these two, and that's opposite. No, wait. If you did write it up here and you did do sine or cosine, you'd get the right answer. It's not really a big deal as long as you were careful and the rounding didn't kill you. Okay, but let's just do it with what we have. Tangent of theta equals 96. Whoops, 90. Terrible. 96.6 over 67.3. And so theta would equal the arc tan of 96.6 over 67.3. Remember to use your parentheses, otherwise your calculator will do the sine of 96.6 and divide the whole thing by 67.3. That's no good. Arc tan, arc answer, and I get 55.1 degrees. Can everybody do this now? Yes. Excellent. We got one more problem to do on this page. We got the bottom problem. I guarantee that I hope you keep your brain on to the bottom problem. Keep your brain on for that bottom problem where it's going to go scary for you.
Was it the flying plane?
I'm not. Thank you. Number 4. Number 4 says a plane is flying at 200 miles per hour, sorry, at 30 degrees. Looking good. That's boring. We can do that. And the second one is 100 miles per hour at 145 degrees. Okay, so here we go. Let's clarify that. Make sure that's really clearly 145 degrees. 145 degrees. So far, so good. Makes perfect sense. Life is good. What do? We break this into components. We know how to do this. That's x. That's y. So we're going to go ahead and go cosine of 30 degrees is equal to x over 200. So 200 cosine of 30 degrees is equal to x. X is therefore equal to, put in my calculator, 187. What do you get? That's not right. 173.2? All right, so now I'm going to do the y sine of 30 degrees. Y over 200. Therefore, 200 sine of 30 degrees is equal to y. Y is equal to 100. So, vector 1, there's an arrow on top, not a -1. Vector 1 is equal to 173.2 I hats plus 100 j hats. So boring. Done this now 3 or 4 or 5 times. Kind of getting bored of this whole thing. Now let's go to the second one. So I draw my tri. So I go to draw my triangle, and Miss Fleming, what's my problem?
You can't have a 90-degree triangle.
I cannot possibly draw this so it's a 90-degree triangle. It's not possible. Therefore, making components suddenly became very, very hard to do. On the other hand, the real question is, how much do I go left, right, and how much do I go up, right? So instead of using the 145 degrees, I'm going to drop a line down to the x-axis, which makes this angle the one I care about. What's that angle going to be in this case? 35 degrees. And then this is going to be my x, and this is going to be my y. Agreed? All right, I can do this. Feeling good again. So I go cosine of 35 degrees equals x over 100. 100 cosine of 35 degrees is equal to x, or x is equal to 100 cosine of 35 degrees, and I get 81.9. I'm going to go ahead and put this here. Those of you who want to say something, just hold off a moment. Now I'm going to do sine of 35 degrees equals y over 100. So 100 sine of 35 degrees is equal to y. Y has to be equal to 57.4-ish. Oops, that should be an I. Listen up like an I. So far, so good? Now I go to do my resultant here. And I'm starting to add this thing up, and I'm feeling good about myself. But there's one other secret evil glitch. And that is this. Notice what we were doing before. We were adding the x and adding another x to it, another x to it, right? This one goes to the right, 173.2. The second one does what? Goes to the left. And so if the triangle is go to the right and then goes back to the left, what should I be doing with those two numbers? Should be subtracting them. Now, if I do 3 or 4 or 7 vectors, it can get really confusing. Which ones do I subtract from which ones? So we're going to make a convention. We're going to agree that if you're going to go to the left, it's going to be negative. And while we're at it, let's make the other convention. If we're going to go down, we're also going to be going negative. So I put a big old minus sign here, and the rest of it's going to be exactly the same as we've been doing so far.
Wait, if you did it, you would still come up with that.
Yeah, you would still go with that. If you like just did it how you usually do it without the making it right away.
But I costed that making it.
That's how I said
Okay, so what do you mean?
instead of like making it a right angle, we just do the same thing. But
You did cosine of 135 in your calculator.
145. Yeah.
Now, you should know
You get negative.
cosine 145 degrees can't possibly exist.
But it's got the same answer.
We'll talk about that later. But you should have been very hesitant to do that. Why?
It wasn't the same answer, but it was just negative.
We all agree what happened there. What I'm trying to make a point is, and I hope you're hearing me,
It's
is
not allowed to.
you know cosine of 135 degrees is BS. How do you know that?
It's only this was 90.
It's a 90-degree triangle. So you got a 90-degree triangle and a 135-degree angle. What's the third side of your triangle?
Nothing.
It can't be. They don't touch. Right? You can't have 100, what would it be, 135 plus 90. You can't have 225 degrees at another angle in a triangle. It doesn't work. Right? So what you did, without thinking about it, okay, you should have thought about it and said, wait a second, that isn't going to work. Yeah.
I didn't think about it.
Okay? So, do it this way.
So what do you get for your
Well, from here on in, it's going to be the same as what you got in your paper. Yeah. I think it's going to be the same from there.
Just making sure.
Yeah. Minus 81.9 is 91.3 I hat plus 157.4 J hat. Redraw. I got 91.3, 157.4, 91.3 squared plus 157.4 squared, square root, and I got 181. Nope, that's not true. 182.0, which I just write 182 because it's a math class. 182 units, miles per hour, at, and then the angle would be 157.4 divided by 91.3, arc tan, arc answer, and I get a lovely, right on the 59.9 degrees. All right, so that negative there is bothering us. That negative right there is bothering us.